Now we will be looking at asymptotes. What is an asymptote? An asymptote is a curve or line that the graph approaches. There are two types of asymptotes, vertical asymptotes and end-behavior asymptotes. The end-behavior asymptotes we will be discussing are horizontal and oblique asymptotes. Vertical asymptotes. To find the vertical asymptotes, find the zeros of the denominator of the function and set them equal to x. The function can never cross a vertical asymptote. This is because at a vertical asymptote, you are dividing by 0, so the function can never be defined at this asymptote. Make sure the zeros of the denominator are not the zeros of the numerator when you're finding this asymptote. If this is the case, the two factors will cancel out, and you will have found a whole, not an asymptote. Let's look at f of x equals 1 over x minus 3. To find the vertical asymptote, set the denominator equal to 0. When you solve, you see that the vertical asymptote is x equals 3. If you look at the graph of this function, you'll notice that it is approaching this line x equals 3, making it the vertical asymptote. Now let's look at end-behavior asymptotes. End-behavior asymptotes, as you can probably guess, are asymptotes that define the end behavior of a function. There are two types that we will be discussing, horizontal and oblique. Horizontal asymptotes. Horizontal asymptotes can be found by observing the relationship of the degree of the numerator and the denominator. If the degree of the numerator is greater than the degree of the denominator, then a horizontal asymptote does not exist. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. If the degree of the numerator equals the degree of the denominator, then the horizontal asymptote is y equals the ratio of the leading coefficient of the numerator to the leading coefficient of the denominator. The function can cross a horizontal asymptote in what are known as crossing points. To find the crossing point, divide the numerator by the denominator, set the remainder equal to 0, and then solve. Now let's look at y equals x cubed over x plus 5. The degree of the numerator is 3 and the degree of the denominator is 1, so the degree of the numerator is greater than the degree of the denominator. This means that there is no horizontal asymptote. If you look at the graph of this function, you'll notice that it is approaching no one horizontal line. Now let's look at y equals x plus 5 over x to the 4th. In this case, the degree of the numerator is less than the degree of the denominator. This means that the horizontal asymptote is y equals 0. If you look at the graph of this function, you'll notice that it is approaching that very line. To find the crossing point for this function, you can set the remainder equal to 0. X plus 5 divided by x to the 4th has a remainder of x plus 5. When you set that equal to 0 and subsequently solve, you'll notice that you get x equals negative 5. This means that the crossing point is negative 5, 0. This is where the function will cross the horizontal asymptote. Now let's look at y equals 9x squared over 3x squared plus 1. In this case, the degree of the numerator and denominator are equal, so we have to find the ratio of the leading coefficients. The leading coefficient of the numerator is 9, and the leading coefficient of the denominator is 3. 9 divided by 3 is 3, meaning that the horizontal asymptote is y equals 3. If you look at the graph of this function, you'll notice that it is approaching that line. To find the crossing point, you would do the long division, and you would see that the remainder is negative 3. This means that there is no crossing point, because negative 3 will never equal 0 under any circumstances. Oblique asymptotes. Oblique asymptotes occur when the degree of the numerator is higher than the degree of the denominator by 1, exactly 1. They're found by dividing the numerator by the denominator. In your asymptotic equation, do not include the remainder. Only include the quotient without the remainder. The function can cross an oblique asymptote in, again, what are known as crossing points. These crossing points are found in the same way you find the crossing points for horizontal asymptotes. Let's look at y equals x squared over x minus 3. To find the oblique asymptote, divide the numerator by the denominator. You get x plus 3 as a quotient, excluding the remainder. So the oblique asymptote is y equals x plus 3. If you look at the graph of this function, you'll notice that it is approaching this line. The remainder of this long division is 9. 9 can never equal 0 under any circumstances, meaning that there is no crossing point for this asymptote.